Hi, my name is Stout. I teach Algebra 1 at Fern Creek High School in Louisville, Kentucky. The lesson I'm going to be going over is solving one variable inequalities. This is like the basic intro, like the first time my students have seen inequalities. We just got done talking about quadratic formula, quadratic functions, graphing, all that. So this lesson will be leading or following that. If you see the I can statements, there's two of them for this lesson. I can solve inequalities with one variable, and then I can represent the solutions to one variable inequalities on a number line. We expect most of our students to be able to solve these just by getting whatever variable it is by itself. Even if they didn't know what the signs meant, whether it's less than, greater than, so on, they should be able to solve for the given variable just by dividing or multiplying. So the first one, this would be the warm-up. The students would come into the classroom on the day. They would have their own sheet of paper. They would answer these 4 questions, like while I'm taking attendance and circulating throughout the room. They would solve these 4. So for example, the first one, you divide by 7. You get x is less than 3. The second one, you divide by 4. So you get x is greater than or equal to -4. The third one, you would want to cancel out the positive 6, so they would subtract 6. It would be 5x is less than or equal to 25, and they would wind up x is less than or equal to 5. And then the last one, 0.5x is greater than 1. Surely they would know how to get this to 1x by multiplying by 2, so x would be greater than 2. So that would be the warm-up. I wouldn't just come here and do it. I would have the kids like volunteer, or I would just use random questioning techniques to call on kids for these 4 questions. I might even have them come to the board and write their answer in front of the class. After we go over this, it takes probably 6 minutes for them to do, and then we go over it, probably takes another 5 or so. And I ask questions at the end, and then we go into the bulk of the lesson. I would probably go over the signs with them: greater than, less than, greater than or equal to, less than or equal to, all that stuff. And then the next part, we would just kind of go over it. I know I only gave 2 examples. We would probably do 7 or 8, like 4 as a class, and then I'll let them work on their teams on the other 4. So the first one is 4x is less than 8. This would turn into x is less than 2 by dividing by 4. They would put their point on the graph. So you have just a regular less than sign, so you put your point, an open circle at 2, and they would shade to the left. And then for part B, 6x is greater than or equal to 24. Divide by 6, you wind up with x is greater than or equal to 4. So difference, the students would go over it, we would talk about it. The difference in the signs makes the difference in whether your point is solid or open. So it would be a solid point at 4. So they would fill that in, and it's greater than, so they would shade the numbers on the number line that are greater. So that's what that would be what we would go over. We wouldn't get into graphing them yet. That would be in the lesson that follows this. And then that would build into systems of linear inequalities. But this is just like the basic intro to this. After we go over it, we talk about all these questions as a class. I call more students up, we do more examples. We would do the exit slip, which is like the last thing. And our lessons our class periods are only like 50 minutes. So between this and this, that would probably take 40 to 45 minutes. And then the last part of the day would be an exit slip for them to take what they've done. Obviously, we just didn't do 2 examples throughout the day. We did more than that. And they would take what they've done. They would answer these 4 questions on their own sheet of paper, and they would turn it into me as they leave. And the answers that I would be looking for on these: 14x is greater than 42. Divide by 14. You get x is greater than 3. So open circle at 3, and you shade to the right. number 2, you would cancel out the negative 7 by adding 7. So you would get 4x is less than or equal to negative 4. You divide by 4, you get x is less than or equal to negative 1. So a closed circle at negative 1, shade to the left. The third one, you get 0.25x is greater than or equal to 2. 0.25, you multiply it by 4 to get 1x. So you would wind up with x is greater than or equal to 8. So you put your closed circle at 8. You would shade to the right. And the fourth one, 5x minus 7 is less than 13. You would cancel out negative 7 by adding 7, so you wind up with 5x is less than 20. Divide by 5, x is less than 4, so open circle at 4. You shade to the left. And obviously I wouldn't go over these with them. This is for them to do on their own and for me to grade and get an idea of whether they grasp this during this lesson or not. Give an idea of whether I should go over it more, or we can move into just the graphing and then the systems of linear inequalities and all that stuff. But that's really it. So I appreciate it. And again, my name is Stout, and thank you.